What's up, good people? This is Mr. Bergman here with section 5.2, solving polynomial equations algebraically. And so last section we did the exact same thing. We were trying to find that one or two or three values of x that solved the equation, and we did that by graphing. And today we're going to do it by algebraically, the techniques. And you remember, just flashback to chapter 3. You remember what we did. What this looked like was finding greatest common factors, splitting the middle, quadratic formula, all that stuff. We're going to bump it up a notch, and we're going to combine them. Sometimes we'll have multiple techniques, and at the same time kind of running together. And it's going to be a wild ride, but here we go together. The big idea is going to be when factoring a polynomial, it's often your responsibility to choose the technique or the combo of techniques that applies. So let's remind ourselves, technique number one, it's a review kind of. You can always do this first, check for the greatest common factor. So you can see here, if we had to solve this, we're like, previously in chapter 3, we only seen exponents as high as 2, but now they're up to 3. So if we're going to solve this, we're like, wait a second, I see 3 terms here and they all have a greatest common factor of a. Factor out the a, boom. And then we got a squared minus 9a plus 14. Okay, I remember how to do this from chapter 3. I can split the middle. And what two numbers but multiply up to positive 14 and also add up to negative 9? That's minus 2 and minus 7 right here. And so then we can split this up into 3 different parts. From this portion, we see that a minus 7 is going to equal to 0, so that's the solution. A minus 2 is going to equal 0, so positive 2 is the solution. And then over here, if a is all by itself, it's basically like a minus 0 is equal to 0. If you put 0 in for a here, then you see it'll also solve the equation. So this equation has 3 different solutions, 0, 2, and 7. Let's do that again. Here, check. It's always a good idea to check for the greatest common factor first. And you can see here, wait a second, we've got t squared is going to be the greatest common factor because the t squared goes into all 3 of these terms. So factor out the t squared. And then we can see over here, we've got this portion of the equation looks like chapter 3. We can do quadratic formula if you wanted to, or I think it's just easier to split the middle. Minus 40, what two numbers multiplied up to minus 40? That also add up to minus 3. That's going to be minus 8 and plus 5. So here from this factor we get, from t minus 8 we get 8, and from t plus 5 we get negative 5. And then of course we've got a t squared over here, which is 0. So that's that. Let's remember that we've got these formulas as well. This is to add to the list of previous techniques. We also have our perfect square trinomial formulas and difference of square formulas. And you remember, if it's in this format, a squared minus 2ab plus b squared, then we can change it into a minus b squared. So the greatest common factor is x. Factor out an x, and then once this is a quadratic, we went, wait a second, this is a squared minus 2ab plus b squared. This is because it's immediately like most recognizable because the first and last terms are perfect squares. If they're only perfect squares if the a were equal to x and if the b were equal to 4. If that's true, then this other side of the formula says that a minus b or x minus 4 is squared. So this x comes down, goes along for the ride. You just recopy it, and just like the equals 0, but we change this factor on the inside to just x minus 4 squared. And so 0 is the number that solves this factor right here, and 4 is the number that solves this part. Even if it's squared, it's still just, there's only one here. It's 4. So there's 2 solutions, 0 and 4. Here, sometimes it's just a lot easier to solve things when they're all set equal to 0, so that's the first thing we can do. We get x cubed minus 3x squared is equal to 0. Factor out an x squared, and so 0 solves this factor, and 3 solves this one over here. Here's a new technique, factor by grouping. First find the greatest common factor of the first half of the terms, and then also the last half of the terms. And the number of terms must be even and 4 or greater. So you got to have like 4 terms or 6 terms or 8 terms. And it doesn't always work. but it's always worth taking a look and see. Maybe it will. So if you have like ax plus bx plus ay plus by, that's kind of the format for what things will look like. You can factor out the x here, you can factor out the y from these two terms here, and then you're left with a plus b and a plus b. So if you see the same thing twice, then you can write it once here, and the leftovers go on as their own factor. Here's what this is generally what the format looks like. Here's what it might specifically look like. You've got four terms, and you can factor out x squared here from the first two terms, boom, and then that leaves you with x minus 2. And then factor out 5 from these two terms, you get 5. And that also leaves you with x minus 2. Now, factor by grouping only works if you see the same thing written twice. So this is x minus 2, x minus 2. Let's go for it. We can proceed. Write it once, and then put the leftovers in another factor. And that's how you factor it. And then if you can factor this other part. But I'll show you what that looks like in a second. All right, so we've got four terms, and we can find the greatest common factor of the first two and the second two terms. The greatest common factor of the first two terms is 3x squared, and then what that leaves behind is an x from this term and a 2 from this term. You can factor out a 4 over here. That's the greatest common factor, and x plus 2 is what's left behind. Then you can see, x plus 2 and x plus 2, that's good confirmation because we see the same thing written twice. We may proceed. If that weren't the same, then you couldn't actually use factor by grouping. There's no guarantee it's always going to work, but in this case it does. So you can write x plus 2 only one time and then put the leftovers in another factor, and that's what we get. If you were to FOIL this out, you go back to the original. Like the f term first, 3x squared times x is 3x squared. Outside term, 3x squared plus times 2 is 6x squared. Inside term is here, 4x, and the last term is 8. But this is reversing the FOIL. Here we go. 1, 2, 3, 4. So now what this looks like if we're trying to solve it, we can see, oh, wait a second, I think we got four terms, and I think I see lots of greatest common factors. Let's try factor by grouping. Let's see what happens. Greatest common factor is 4x squared. Now, it's not just 4, it's also the variable part of the x squared as well. And what's left behind, it's x and then a 3 from this term. I think we can factor out a minus 9. And so when you factor out a minus 9 times what gives you minus 9x? Oh, it's just x. Minus 9 times what gives you minus 27, positive 3. And look, oh, happy day, we've got x plus 3 twice. It's written twice, so therefore we can actually proceed with factor by grouping. So we write it just once here, and the leftovers go on the other side, and then equals 0. Now the leftovers actually can be further factored. The indicator here is that we've got the x squared. This is, remember from quadratics, we've got this as a plus, or this is a difference of squares. 4x squared is a perfect square, 9 is a perfect square, and we've got subtraction in the middle. So therefore we can say this is 2x plus 3 and 2x minus 3. Each one of these three factors each produces its own solution. Minus 3 comes from this one, and then 2x plus 3 equals 0 turns into negative 1.5, and 2x minus 3 equals 0 turns into positive 1.5. And you list them all out. All three of them get listed here in the solution set. Factor by grouping even more. Okay, whoa, Nelly, we got 1, 2, 3, 4, 5, 6 terms. Good night. All right, let's group them into two different sets. Let's see, the first 3 and the second 3 here. If you're going to use factor by grouping, you need to make sure that you can find a greatest common factor between the first half of the terms, and then also a different greatest common factor for the second half of the terms. And we can. The greatest common factor that goes in the first 3 terms here is, I've also rearranged them. The order of these is I've grouped them in, like I saw that there were two different kinds of terms. There were terms that had x squareds, and there were terms that had y's. And so I put all the x squared terms here, even grouped them with parentheses, and then group the y terms over here with parentheses, because I'm going to factor out an x squared here and a y here. More than just x squared, I'm going to factor out 7x squared. So this becomes, the leftover becomes 2a. This was 28b x squared. It's just going to be 4b, and then minus 5c, because 7x squared times minus 5c is minus 35cx squared. And over here, we can factor out a minus 4y. They've all got y's, and they're all numbers that multiply with factors of 4. And what's left behind is 2a plus 4b minus 5c. Hooray, hooray, we actually can use grouping because we've got 2a plus 4b minus 5c on both of these giant terms. So it's written twice, so that's the one thing we're going to write just once. And then the leftovers become 7x squared minus 4y. Wowzers, that was a little intense. Let's see what else we got over here. We're going to do it again. 6 terms. That's a mess. We can do this. I see x squared. I see y terms that have x squared. I see terms that have y squared. And they're all like that. Let's see. Let's group them together. We've got 3 of them over here. We'll group all the x squared terms first. And then in another set of parentheses, we'll put all the y squared terms over here. Okay, so let's factor out the x squared. And we can also factor out a 6. So 6x squared. 6x squared times what gives you 12ax squared? 2a. 6x squared times what gives you minus 18bx squared? Minus 3b. 6x squared times what gives you 24cx squared? 4c. I'm going to play the same exact game over here. I think I can factor out definitely a y squared, and then all 3 numbers also factor out a minus 5. So we've got minus 5y squared times what give you minus 10a squared? 2a. Minus 5y squared minus 5b. Ooh, this should be a 3b right here. 3. Yeah. Okay. Plus 4c. Okay, so then hooray, hooray, we've got the same thing written twice, 2a minus 3b plus 4c twice. So we'll just write it once down here, and then multiply it by, as in a set of parentheses, collect the leftovers, 6x squared minus 5y squared. If you were to multiply this out using the box technique, if you were to multiply this out using the box method of multiplying, kind of like foiling out a 2x3 box, you would get these 6 different terms. Wowzers. All right. Here's another technique. We got some formulas. You remember the difference of squares formulas. In fact, let's review them a little bit. You can always check for the greatest common factor first, and then choose a and b to find the right formula. So difference of squares could look like this. 9x squared minus 16. Oh, I remember this perfect square. This is a perfect square. This is a perfect square. Subtracting them. What times itself is 9x squared? Oh, that's 3x. What times itself is 16? That's 4. So we can write 3x plus 4 and 3x minus 4. And we're using our formula here. A plus b, a minus b. Let's see, the a value for this is probably going to be 2x. The b value is going to be 9y. So we write 2x plus 9y, 2x minus 9y. Great. This is we're still reviewing, but we can check for the greatest common factor first. So let's factor out a 3 from both of these terms like this. And then a value is x, b value is 5y, because 5y times itself is 25y squared. There's subtraction there. We got a difference of squares. So we can write 3 times x plus 5y and x minus 5y. These are 3 different factors, 3 things being multiplied all by themselves. That's how you factor. Perfect square trinomial. Remember, there's a positive and there's a addition version of this and a subtraction version. And so I recognize when I see 9x squared plus 6xy plus y squared, the first term is a perfect square, the last term is a perfect square, and this middle term kind of smells like both of them and is doubled. So we can see here, if we choose a to be 3x and b to be y, then this would be a squared, and this would be b squared, and this would be 2 times a times b. And so therefore we can see this is a plus b squared, or 3x plus y squared. All right, we got some subtraction going on. here, I think this is a perfect square and this is a perfect square. So this 3 squared, what the square root of 9 is 3. The square root of c squared d squared is going to be just cd. And the middle term is, in fact, 2 times a times b. 2, that'd be 6cd. So then, therefore, we can say this is a minus b squared. Boom. Perfect square trinomial? Yeah, I think this first term is a perfect square. Its square root is 8x. This last term is a perfect square. Its square root is 1. And so therefore, and the middle term is going to be 2 times a times b. We'll use the addition version because I see plus here. So this is going to be a plus b, or just 8x plus, and you tell me, squared. So I'm not going to prove these at the moment, but there's some new formulas in the same vein. We had squareds, and now we're going to have cubes. That's kind of the theme for chapter 5. Whatever we did in chapter 3 with quadratics, we're going to bump it up to a higher exponents. And welcome, you can, if you want to, you can FOIL these out in a giant box, and you can, like box method, 2x3 box method, and you'll see that most of the terms cancel out, and you're just left with a cubed in the top left corner and b cubed on the bottom right corner of that box. So this is actually a formula. And anytime we see something that looks like this, we can factor it in something that looks like this, making sure to choose the a and b wisely. The first term is a perfect cube. The cube root of 8 is 2. The cube root of x cubed is x. So the a term is going to be 2x. The cube root of 125, what number times itself 3 times is 125? Oh, it's 5. Being Mr. Bergman, I have all that memorized, and maybe you'll have it memorized too soon. What times itself 3 times is y to the 12th. It's going to be y to the 4th. Y to the 4th times y to the 4th times y to the 4th is y to the 12th. So we've chosen A and B, and now it's super important to, I think, write this out because it's going to be harder than ever to plug it into the formula. So this is going to be A plus B here, A plus B, times A squared. Well, A squared is going to be 2x squared, which is 2x squared, the entire term squared, which is 4x squared, minus A times B. Notice there's a subtraction here, even though there's no subtraction here, which is it's going to feel a little different, I think. A times B, 2 times 5 is 10, x times y to the 4th is xy to the 4th. And then b squared, 5y to the 4th times itself is 25y to the 8th. Wow, that's a lot. There's another version of this. This is the sum of cubes, and we've got the difference of cubes. And the formulas look very, very similar. You notice this is subtraction here, but there's addition here. A little strange, not used to it, but maybe after some practice you'll be. All right, so, wow, okay. I see a 54 and an x to the 5th. I see 128, x squared. Wait a minute, I think there's a greatest common factor we can factor out first. These are both even, so we factor out a 2, but I don't think we can factor out anything more. And then x to the 5th and x squared, we can factor out an x squared. So 2x squared is the greatest common factor. 2x squared times what gives you 54x to the 5th? 27x cubed. And then 128 x squared, y cubed, divided by 2x squared, it's going to be 64y cubed. You notice if you distribute this, you get back to the original. It's a good check anytime you're wondering whether or not you did it right. Okay, so now, we've got 27, that's a perfect cube. 64, that's a perfect cube. And I think what we've got here is a difference of cubes. The formula is only going to work if I choose A to be 3x, because 27, what times itself 3 times is 27? It's 3. And what's the cube root of x cubed? It's x. What's the cube root of 64? It's 4. The cube root of y cubed is y. So if A equals 3x and B equals 4y, then we can actually apply this formula. And we go from here to the right-hand side. Notice the greatest common factor is going to go along for the ride. We just recopy it, and now we have to write a minus b, which is 3x minus 4y. We have to write a squared, which is 9x squared. A times b, 3 times 4 is 12xy. And then b squared here is going to be 4y squared, which is 16y squared. I don't see any greatest common factors here, so I think what I'll do is I will say that the cube root of 8 is 2. The cube root of c cubed is c. The cube root of 27 is 3, and the cube root of d cubed is d. A is going to equal 2c, b is equal to 3d, and I'm going to apply my formula. So the formula, you notice there's subtraction here, so I'm going to apply the difference of cubes formula, and I'm going to write down a minus b, which is here, a minus b, and then a squared, which is here, 4c squared, a times b, which is 6cd, and then b squared is going to be 3d squared, which is 9d squared. All right, let's keep on going with this. Combos. We've learned multiple techniques. We're going to use a couple of them in the same problem, kind of like what we've been doing already. All right, so I see this looks like a difference of cubes. I mean, yeah, difference of cubes, because 64 times the cube root of 64 is 4. The cube root of x to the 6 is x squared. What times itself 3 times is y to the 6? Oh, it's y squared. Using our formula, we can write this out. Here, 4x squared minus y squared times 16x. So this is a minus b. This is a squared plus b squared plus a times b plus b squared. I think we can do this again, because this term generally is usually not factorable, but this looks like a difference of squares. This is, if we let a equal 2x and b equal y, then we can use the difference of squares technique, and this term gets divided into 2x plus y and 2x minus y. And the giant long term over here just gets recopied and down for the ride. And now we factored it into 3 different sets of parentheses, 3 different factors. We've got a greatest common factor here. This is going to be if x to the 6th y cubed minus 9 y to the 9th, there is a certain number of y's that are the factor of in both of them. The greatest common factor is y cubed. Put that up front. Y cubed times x to the 6th gives you this, and y cubed times y to the 6th gives you this, which is why it's here. Now it looks like we've got a difference of squares. But hold on, it's not just a difference of squares, it's also a difference of cubes. It's both, because it's a difference of x to the 6th, something to the 6th power. So I think what I'm going to do is I'm going to use the difference of cube formula first, and although it doesn't matter which one you use. So I'm going to say this is going to be, we're going to use the difference of cube formula. A is, so what times itself 3 times is x to the 6th? It's x squared. What times itself 3 times is y to the 6th? Oh, it's y squared. So a will be x squared and b will be y squared. We're going to use our formula that you can see above. The greatest common factor goes down for the ride, and we're left with a minus b times a squared plus ab plus b squared. This term is generally never factorable because of the format. If there were a 2 in front of here, we'd be able to factor it. It kind of looks, this formula looks a whole lot like, I should have mentioned this earlier. This portion of the formula looks a whole lot like a perfect square trinomial. A squared plus 2ab plus b squared. But notice there's no 2. And since there's no 2, you really can't apply the formula to it. So x to the 4th plus, so explain this line. So now what we're going to do, we're going to say this is a difference of squares. And so although this gets recopied down, and just recopied and goes along for the ride, and so does this giant long-term one over here, this one actually gets split up into 2. It's x squared minus y squared, and so you get x plus y and x minus y here. I didn't show a whole lot of work for that last step, but I hope it's okay. We got a greatest common factor. I see a's and b's and multiples of 5, so it's going to be 5a. Oh, there's only one a here, so the greatest common factor is a. There's only 2, the lowest exponent here is 2. So the greatest common factor that all 3 of them have is going to be 5ab squared. Any greater than that, like b cubed or a to the 4th or something like that, and it won't be present in all 3 terms. So we're going to factor out 5ab squared. We factor out 5ab squared, and you ask yourself, 5ab squared times what gives you 5a cubed b 4th? Oh, that's just a squared b squared. 5ab squared times what gives you 10a squared b cubed? That'd be 2ab. And 5ab squared times what gives you 125ab squared? Just 25. Oh, and look at this. Oh, this is super tricky. This looks like a perfect square here and a perfect square here, and so I'm going to use the perfect square trinomial formula. This is a squared plus 2ab plus b squared. If we let the first part be ab, this is super tricky because it's capitalized and non-capitalized letters, uses of the a and b. But the b is going to equal 5, and so therefore we can say this is ab plus 5 squared. Wowzers, that's a ton. All right, thanks for paying attention. Bring your questions, and we'll talk about this in class.